Imagine a world where machines think like humans. This is the world of artificial intelligence, or AI. But how did we get here? The story of AI is as old as human imagination itself. From ancient myths to modern reality, AI has captured our minds. We've always dreamed of creating lifelike beings that could think and reason like us. This dream has driven us to push the boundaries of technology. The roots of AI go deep into our past. Ancient civilizations had their own versions of artificial beings. Take the Greek myth of Talos, for example. Talos was a giant bronze man who protected Crete. He was an early concept of an automated guardian. Then there's the Chinese philosopher Mozi. In the 5th century BCE, he described a mechanical man. These early ideas were just the beginning. They planted the seeds for what would become AI. The journey from myth to reality was a long one. For centuries, the idea of artificial beings remained in the realm of fantasy. But as technology advanced, so did our ability to turn dreams into reality. The Industrial Revolution marked a turning point. It showed us the power of machines to transform our world. In the 19th century, the concept of thinking machines began to take shape. Writers and thinkers started to explore the idea in earnest. Mary Shelley's Frankenstein touched on the theme of artificial creation. It raised questions about the nature of life and consciousness. These questions would become central to AI research. In 1920, Czech writer Karel Čapek introduced the term robot in his play Ruar. The word comes from the Czech robota, meaning forced labor. This idea would influence how we think about AI for decades to come. Enter Alan Turing, a British mathematician and computer scientist. Turing is often called the father of modern computer science. His work during World War II was crucial in breaking the Nazis' Enigma code. In 1950, Turing published a groundbreaking paper. It was titled Computing Machinery and Intelligence. In this paper, Turing proposed a test. We now call it the Turing test. This idea set the stage for AI research. Turing laid out many key concepts in AI. They're still central to AI research today. He predicted it would happen by the end of the 20th century. The summer of 1956 marked a turning point in AI history. A group of scientists gathered at Dartmouth College. Their goal? To explore the concept of thinking machines. This event is now known as the Dartmouth Conference. It's widely considered the birth of AI as a field of study. The conference was organized by John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon. These names would become legendary in AI circles. McCarthy coined the term artificial intelligence during this conference. It was a bold declaration of intent. They weren't just talking about advanced calculators, they were aiming to create machines that could truly think. The proposal for the conference was ambitious. It stated, every aspect of learning or any other feature of intelligence can be so precisely described that a machine can be made to simulate it. This belief set the tone for AI research. It suggested that human intelligence could be replicated in machines. The participants were optimistic about the future of AI. The years following the Dartmouth Conference were marked by rapid progress. Researchers were filled with optimism. They believed that human-level AI was just around the corner. This period, from the mid-1950s to the mid-1960s, is often called the golden years of AI. One of the early successes was the logic theorist. Created by Alan Newell, Herbert A. Simon, and Cliff Shaw, it was designed to mimic human problem-solving skills. The program could prove mathematical theorems. It even discovered a more elegant proof for one theorem than the original. This was a major milestone. It showed that machines could not only calculate, but reason. Another significant development was the General Problem Solver, or GPS. Also created by Newell and Simon, GPS was designed to solve a wide range of problems. It used a method called means-ends analysis. This involves breaking down a problem into sub-goals. GPS could solve puzzles and prove theorems. It was a step towards creating a machine that could think like a human. The optimism of this era led to bold predictions. Despite the early optimism, AI faced significant challenges in the 1970s and 1980s. This period is often referred to as the AI winter. Progress slowed, funding dried up, and public interest waned. The grand promises of the 1960s had not materialized. AI was facing a reality check. One major issue was the limitation of early AI systems. They could handle simple tasks in controlled environments, but they struggled with more complex real-world problems. Language understanding, for example, proved much harder than expected. The nuances of human communication were difficult to program. AI systems of the time lacked the flexibility of human intelligence. Another challenge was computational power. The computers of the 1970s and 1980s were not powerful enough for advanced AI. Many AI algorithms required massive amounts of data and processing power. These resources simply weren't available at the time. This limited the scope of what AI could achieve. Funding also became a major issue. Government agencies and corporations had invested heavily in AI research. The AI winter didn't last forever. In the 1980s and 90s, a new approach emerged: machine learning. This shift would revitalize the field of AI. Machine learning focuses on creating systems that can learn from data. Instead of being explicitly programmed, these systems improve with experience. One key development was the resurgence of neural networks. These are systems inspired by the human brain. They consist of interconnected nodes like neurons. Neural networks can recognize patterns in data. They're particularly good at tasks like image and speech recognition. In 1986, the backpropagation algorithm made training neural networks more efficient. Another important advance was the development of decision trees. These are models that make decisions based on a series of questions. They're useful for classification and regression tasks. Decision trees form the basis of more advanced techniques like random forests. These methods proved effective in many real-world applications. As we entered the 21st century, AI began to permeate our daily lives. Often we don't even realize we're interacting with AI. It's become a seamless part of many technologies we use every day. From smartphones to smart homes, AI is everywhere. One of the most visible applications is virtual assistants. Siri, Alexa, and Google Assistant use AI to understand and respond to our voice commands. They can answer questions, set reminders, and control smart home devices. These assistants use natural language processing and machine learning. They improve their understanding and responses over time. AI is also revolutionizing transportation. Self-driving cars are no longer science fiction. Companies like Tesla and Waymo are testing autonomous vehicles on real roads. These cars use AI to perceive their environment, make decisions, and navigate. While fully autonomous cars are not yet widespread, driver assistance features are common. These include adaptive cruise control and automatic emergency braking. In the realm of entertainment, AI is changing how we discover and consume content. In recent years, a subset of machine learning has taken center stage: deep learning. This approach uses neural networks with many layers. These deep networks can learn complex patterns in data. They've led to breakthroughs in many areas of AI. One of the most impressive applications of deep learning is in image recognition. In 2012, a deep learning system called AlexNet achieved record-breaking performance in an image recognition competition. It could classify images with unprecedented accuracy. This sparked a revolution in computer vision. Today, deep learning powers facial recognition systems and medical image analysis. Deep learning has also transformed natural language processing. Systems like GPT-3 can generate human-like text. They can write articles, answer questions, and even code. These models are trained on vast amounts of text data. They learn patterns and relationships in language. While they don't truly understand language, their output can be remarkably coherent. As AI becomes more powerful, ethical concerns are coming to the forefront. We're grappling with privacy, job displacement, and algorithmic bias. Privacy is a major concern. AI systems require large amounts of data. This data can be misused. Job displacement is another issue. AI is taking over tasks once done by humans. But it's also creating new jobs. Algorithmic bias is a subtle problem. AI can perpetuate existing biases. Despite challenges, the future of AI looks bright.